In this example, we're required to find a 95% confidence interval for the mean, and all we've been given is, in this case, 8 randomly selected juice bottles in which we have the amount of juice in each bottle. We need a 95% confidence interval for the mean. So the information is going to come from our sample, and the calculator is very helpful here. We can use it to calculate most of what we need. Let's start by going into the menu, into the stats mode, and inputting the values we have given to us. So we need to put in 15.1, 15.1, 15.6, 15.6 again, 15.2, 15.4, 15.3 and 15.8. The calculator will work out the values for us if we press F2, calculate, and it's a single variable. Each of these appears with the frequency of just 1, and all the information we need is there. Now remember, the examiner will expect to see how you've calculated these things. So first of all, our mean, which of course is a best estimate of our population mean, is equal to the sum of x divided by n. So we can help explain how we arrive at that answer by copying down those values. But of course our calculator has worked that out for us to be 15.3875. Now if you're required to report on that figure, remember you would round that off to be 15.4. However, the figure we have will be used in our calculation. We won't round off for the calculation. Now we've got to work out an estimate of the population variance, and for that we're going to use Sn-1 squared, and that formula is n over n-1 into the sum of x squared over n minus the mean squared. So those figures will be 8 over 7, and sum of x squared will be 1894. Remember, all of these figures we're just copying straight from our calculator and convincing anybody reading it that the formulas are being used. So we have that divided by 8 minus, in this case our mean value is 15.3875 squared. So we can calculate that, and from that we can say that Sn minus 1 is equal to, well, that information is contained on the calculator. It's the symbol x sigma n minus 1, and that's equal to Sn minus 1. So we can pick that figure straight from the calculator to be 0.25877458. Now we're in a position to work out our confidence interval. Our confidence interval is going to be based on our mean, plus or minus. And to do this, we need to calculate the appropriate t-values, because we're going to use a t-distribution because we don't know the population variance. So we need the t-value corresponding for a 95% confidence interval. The t-value at the end will be at the figure 0.975, and we'd multiply that by our standard deviation, which we've just estimated, which is Sn minus 1. We divide that by the square root of our sample size. So here we're going to have 15.3875 plus or minus the t-value, which we do not need to state there, but we do have the other values, 0.2587748 all over the square root of 8. Now the confidence interval that produces can be done on our calculator. We exit the information we have. Remember, that's now stored as a list. So exit again. Go into the interval F4 button, and we're using the t-distribution F2, and it's a single sample F1, and our data is in a list. We're looking at a 95% confidence interval. Our data is in list 1, and each of the values occurs with a frequency of 1. That's fine. And we just now need to calculate. Confidence interval is therefore from 15.2, that's 3 significant figures, to 15.6, taken straight from our calculator.